Hello, Algebra 2! I hope you guys are having an awesome day. So, we're starting chapter 5. Chapter 5 is mainly about rational functions, but we're not getting there today. Today we're just going to talk about variation functions, um, inverse functions, and direct functions, and then joint functions. So we're just going to talk about those, have a couple examples, and yeah, that's about it. Nothing too exciting. But it's going to be awesome. Okay, so first we're going to talk about what a direct variation is, or a direct relationship. It is a relationship between two variables, x and y, that can be written in the form x equals k times y, where k is just like some constant. So basically, x equals a number times y. So basically what happens is if you have a direct relationship, right, as one thing increases, the other thing also increases. And so I'll show you an example of what that actually means. But if you rearrange it and you divide by y, you get x over y equals a constant. So every time you divide an x value by a y value, as long as they follow this relationship, they're always going to equal that constant. So I'll show you an example of what that means. All right, so our first example is about Vail, because we live in Colorado, and that's exciting. So n which is the number of skiers currently at Vail, varies directly with S, which is the number of inches of fresh powder. So, if there are 40 skiers when it has snowed 1 inch, find out how many skiers there will be when we have 10 inches of fresh snowfall. So basically what you have to do is you have to figure out what the constant is, and since you know it's a direct relation, you can set it up like n equals some constant, we don't know what it is, I'm just going to call it k, times s. You know I hate using s as a variable, but s is for snow. So there you go. And they give us some information. So they say if there's 40 skiers, so n is 40, and that equals k, which we don't know yet, times the amount of snowfall. It says 1 inch. Then we can figure out what k is. Okay, you divide by 1 and you figure out that k is actually equal to 40. Well, that's convenient. So now you know the function is going to be n equals 40 times s. So then the next question says, how many skiers do you expect when we have 10 inches of fresh snowfall? So now s is 10, but we already know what k is, so we just plug it in. We say n is equal to 40 times 10. We would expect 400 skiers. All right, next is an inverse variation or an inverse relationship. I'll probably use the word relationship a little bit more, but your book uses the word variation. Just use them interchangeably. Not a big deal. But anyways, so similar kind of relationship, except as one variable goes up, the other variable goes down. So it's an inverse relationship. So the way you write this kind of a relationship is like if you have x and y, x is equal to some constant over y, because that means like as x gets bigger, y is going to get smaller. Okay, so k still can't be 0. K is still just a constant. And then what ends up happening with that is you can rewrite it and like x times y equals k. So basically what that means is that the product of any x value and y value on this relationship is going to be the same amount every time. So that's kind of nifty. All right, so this seems pretty relevant, I think. And it's a good example, I think, of an inverse relationship, yes, because the number of dates you have in a year tends to vary inversely with the number of AP courses you take, or even your GPA. And so they give you some information so you can figure out the constant. So if somebody's taking 2 AP courses and can get 17 dates in a year, which is actually quite a lot of dates, how many dates could someone taking 5 APs get? So you set up your basic formula. So we let D equal our number of dates, and it's inverse, so we know that our A is in the denominator, because as the number of dates goes up, our number of APs goes down. And as our number of APs goes up, the number of dates goes down. So we have some constant here, and then they give us some information so we can figure out our constant. So it says if someone taking 2 AP courses, so that's K over 2, can get 17 dates in a year. So that equals 17. We need to figure out our constant. Okay, multiplied by 2, you get K equals 34. Not too bad. So then you can set up your actual function by replacing K with 34. And then you can answer any other questions about the function. So it says, and how many dates could someone taking 5 APs get? So then you would plug in 5 for A for your APs, and then figure that out. So you end up getting something like 6.8-ish dates. We're going to round that to 7 because that'd be a pretty rough 0.8. 0.8 dates, ends early. I don't really know. Something crazy. So your number of dates is approximately 7. Okay, so that's an inverse relationship. All right. Lastly, we have the joint variation, which involves more than 2 variables. So more than likely it'll only be 3, but you never know. We might have some really fancy schmancy relationships. All right, so in general, this tends to be something like x equals a constant times y times z, but you might have a case where x varies directly with y, but indirectly, inversely with z. And so you might have different setups depending on the situation. Again, k cannot equal 0. Good question. Why can't k equal 0? Think about that for a second. If k is 0, what is the relationship? Okay, so hopefully you're able to figure that one out. If not, ask me in class. But, so we've got an example of a joint variation, which has 3 different variables that are related to each other by a constant. So you've got your weight, which varies jointly with how many calories you eat and your stress level. And so since they didn't say any of them are inverse, and it kind of makes sense, right? As soon as your calories increase, your weight increases, and as your stress level increases, you tend to gain weight as well. So your setup is going to be something like W, your weight, is equal to a constant times my calories times my stress. Again with the S variable. Hate that. Okay, anyways, we gotta figure out what our constant is first. And so they give us enough information to figure that out. If someone weighs 120 pounds, so I'm going to plug that in, 120, eats 3,000 calories a day, because their stress, we're going to count our stress level on a scale of 1 to 10 for the sake of this problem, times our calories, times our constant, times our stress level, which is 1. Then we can figure out what K is. And then we can answer the other question. So we get K is equal to 120 over 3,000, which if you just plug that in your calculator, you get K equals 0.04. All right, so the next question is, if I have somebody who's eating the same amount of calories, 3,000 calories, but I'm at a stress level of 10, what is their weight going to be, or what would we predict their weight to be? So then you just set up your formula. We don't know our W, and then we plug in our constant and our calories and our stress level, everything we know. Hopefully this person figures out how to reduce their stress level, or at least their eating, because they'd be 1,200 pounds, which is ridiculous. They would die, I think. Okay, at this point I would recommend pausing it and trying the next couple problems, before I do them and show you the answers. So pause. Okay, you ready to go? So classify the following as a direct, inverse, or neither. First one, as m increases, p increases, that's direct, A. The second one, c and e over -4. As c increases, e is also going to increase, so that is also direct. And look at the last one, also c equals 3v. Well, as c increases, v increases. This is also direct. My problems are varying quite a lot there. Now, if you're confused about 2, you can rewrite e over -4 as 1 over 4 times e. And so that's still a direct relationship. Okay, pretty easy. Constant of variation. The first one is just 4. It's whatever your constant is. And then the second one is -0.2. That was super difficult. Oh, and we already talked about these. If x and y vary directly, as x decreases, y also decreases. And if x and y vary inversely, as y increases, x will decrease. And I think that's it. So cool. Have a great day. And don't forget, I told you before, don't mess with chubby cheeks.